All right, so again, a hot air balloon begins descending at a rate of 20 feet per minute and from an elevation of 1,350 feet. Write an equation to model the balloon's elevation as a function of time. What is true about the slope of this line? So we are going to write a linear equation in slope-intercept form. Now, they didn't give me 2 points. They've given me a rate and a starting point. So the rate would represent which one, the slope or the y-intercept? The rate. 20 feet per minute. Lexi? Good, this is your slope. Slope is also known as your rate of change. Now, because it says descending, what do we know about the 20? Abby? The line is negative. So descending is going to indicate that this is a negative slope. So you kind of want to add in a negative 20. If it had said that it was ascending or rising, then we would keep it as a positive rate. So we have to use that word to insert that symbol. And then from an elevation of, so that's your starting point, and then you're descending, this would be your y-intercept. So all we have to do is plug those in. And it says, what is true about the slope of this line? And that would be that the slope is negative because it is descending. Now, normally when we graph something in slope-intercept form, we just start at the y-intercept and we would count the slope. Now, because these numbers are rather large, we oftentimes when we graph them, we'll have to count by different units on different axes. Okay, so we need on this axis to get all the way up to 1,350.
Pardon the interruption. Tristan Bowman, if you're in the building, please come to the main office. Tristan Bowman, if you're in the building, please come to the main office.
And let's suppose that we count by, I don't know, 50s or hundreds, probably hundreds to get to 1,000, maybe even 20s. Sometimes what you count by won't match up with your slope. So you're not really just counting down and over. So when you do these problems, sometimes you can structure it so that you did count by 20, so that you're going down 20 and over 1. But usually you're going to want to create a table of values. Okay, so to create a table of values, we'll just create a little XY table. We will pick X values and then we'll plug them into the equation to get the corresponding Y value, and then we'll plot them. Okay, now some of the critical points that you'll want to plot are your two intercepts. So you would want to plot your y-intercept, which of course is when X is 0. So if I plug in 0, negative 20 times 0, we know it's just going to be 0. So we definitely want that to be plotted. Now, if you look ahead at question B, it says graph the equation and interpret the intercept at which the graph intersects the vertical axis. Okay, it's also going to want us to do the horizontal. So if the airplane is descending, we do want to eventually find out when it lands at what time. So we would also want to find out the x-intercept, which is when y is 0. Okay, so to do that, I'm going to plug in 0 for y in the equation. Go ahead and solve that out for x. And see what we get. We actually can just plot those 2 points and connect them with a line with our two intercepts. What we got for our x-intercept?
675.
Say again?
675.
No. Not 600. Should be 67.5, so I think you just forgot to move a decimal in there. If you wanted to do it, you could take out the zeros and just do 2 into 135 instead of 20 into 150. So we really could just plot these 2 points. That's going to be enough. Okay. So I need to be able to get up to 1350. So hundreds won't do it. Okay. I think I probably chose 200s to get up there, but you could have probably done 150s as well. You also want to label the y-axis, which is your balloon's elevation, which would technically be in feet. So on your homework, you'll have to pick the appropriate scale. You don't want to do the scale until you get your critical points, okay, so that you know how far out you have to go. I mean, if you want to skip every other space and put like 400, skip a space 800, you don't have to write them all out as long as I can understand what you're counting by. And then across this axis, I need to get out to at least 67.5 so that I can see where it's landing. So I chose to count by tens. And again, that's our time in minutes. So please make sure you do label these axes because you will lose points if you forget that, if it's a real world problem. And then all you're going to do is plot your 2 points and connect your dots. Now you will connect these with a segment instead of a line with arrows, just because you're not going to have negative time and the balloon also isn't going to go below the ground. Does that make sense? And let's interpret where it intersects our vertical axis. So when time is 0, the balloon was 1,350 feet above the ground. And then I'm also going to add in, a lot of times it will ask you, what does the x-intercept represent? And so you would represent that the balloon's elevation would be 0, which means it has landed on the ground at a time of 67.5 minutes. Okay. So the balloon All right, now the next one is the same type of problem, but instead of descending, it is elevating. Okay, so it's rising up. And when you do the rising up ones, your line is going to look like this. So you won't need a critical point at the end because we don't know when it's going to stop rising. Eventually it will. But we don't know that part. So when you do an elevation problem, you really just have to have your y-intercept. And then if you want, you could count slope up and over if you were to count by appropriate terms. Otherwise, you're just going to pick a couple other points and plot them until you get a line. So this one says a hot air balloon takes off from Jacksonville, Florida. So Jacksonville, Florida is already above sea level at 12 feet. So that would be my y-intercept, my starting elevation. And it rises, which would be a positive slope, at a rate of 50 feet per minute. So our equation would be y equals 50x plus 12. And always make sure that your units match. I feel like in the homework tonight, it'll do inches and feet or something. So make sure that you always have constant units before you write an equation, so you can see that we do have feet and we have feet per minute. Okay, see if you guys can go ahead and graph that, labeling your axes, and then we'll compare our answers before we take a look at the other word problem without a graph. Whenever you're doing these problems, depending on what you pick, I'll make sure that your scale is appropriate for whatever you choose. Abby?
So we do have the arrow at the top now.
Correct. Very good. We do have an arrow at the top because it is ascending and we don't know when it stops. according to our model, it goes on forever, but we know eventually it would stop in the real world. So again, interpret the intercept at which it crosses the vertical axis, which we know is our y-intercept, because this is our vertical line. So that would be the starting elevation. Which kind of seems redundant. That was before it took off, okay, at time 0. 0 seconds, or 0 minutes, excuse me. Again, make sure you have your axes labeled. The homework, you will see different types of questions, not all hot air balloons, but they're all the same type of question. Pay attention to the wording that you might see. Again, we saw descending was negative. Another phrase that could be negative would be decreasing. So if you were, something was decreasing in size, that would be another indication of a negative. So the only time that you have to have that other critical point is if it is a descending, okay? Because you'd want to show the whole graph. All right, on the back we have a linear model without a graph. And they want us to write a linear equation to model this. And then they also want us to answer a couple questions. Now, you'll notice when we read through this question, at no point does it tell us a rate. It says a candle is 6 inches tall after burning for 1 hour. And after 3 hours, it is only 5.5 inches tall, okay, because it's dwindling down as it burns. Write a linear equation to model the height, y, of the candle after burning for x hours. So they did define the variables. Okay, y equals the height of the candle. Sometimes they won't do this. And we'll look at those tomorrow, where you'll have to determine which one's independent, which one's dependent. And our x variable, they tell us, is the number of hours that it has been burning. So what we want to do is go back to the two pieces of given information and label them with an x and a y, and we'll create two ordered pairs. So this one, 6 inches, is a height, that's a y value. After 1 hour is an x value. So I'm going to take those two numbers and I'm going to put them together as an ordered pair, which is always x comma y, which would be 1 comma 6. If you were to make it 6 comma 1, the linear model would not be correct based on how they define the variables. So just be careful. And then after 3 hours, which is our x time, it is about 5.5 inches tall, which I would make that 5.5 maybe just to make your math a little bit easier. That's our y. So our other ordered pair would be 3 comma 5.5. They want us to write a linear equation. How could we write a linear equation if we have 2 points? What's the first thing we would have to do? Gary? Good. You have to find the slope. Using your y2 minus y1 over x2 minus x1. Point 1, point 2. Now, since we're still not using a calculator at this point, how can I change this into something that's easier to work with? It has a decimal fraction. Abby? Yes. By multiplying each of these by 10, we can move the decimal over, so this will become -5/20ths. And then we can reduce -5/20ths to be -1/4 or -0.25. Okay? Whichever one you prefer working with without a calculator. So we have now the point, or excuse me, 2 points and the slope. So we're now going to go to point slope. Which you did this on your quiz yesterday as well. And again, I usually pick the first point, but you can pick the second point if you prefer it, but it's already labeled for me. And the first point doesn't have decimals, so that's another reason that you might want to pick it. They didn't tell us what form we want it in, but I would like us to change this back to slope-intercept form. So go ahead and distribute. We'll get negative 1/4 x. Now be careful, a couple of you on your quiz were making the mistake of forgetting two negatives. When you multiply them together, will get me a positive 1/4. And then we'll add 6 to both sides. Okay, at this point, you might want to think of the 1/4 as 0.25, and then you can just make it 6.25, since we're doing this without a calculator. Or you could find a common denominator and all that stuff. Or you could just make it 6 1/4 if you want to leave it as a mixed number too. That would work. So what does the slope represent? Okay, well, we know the slope is negative, but we want to relate it to the actual words. So remember, the slope is the change in y over the change in x. If you look at the formula, it's y2 minus y1 over x2 minus x1. So if you look, the y was our height of the candle in inches. So that means that the height of the candle is decreasing 1 inch let's say decreasing 1 inch every 4 hours. Now, if you were to do it using the decimal, you could also say that the candle is decreasing 1/4 of an inch, or 0.25 inches every 1 hour, is another way you could describe the same slope. Okay, just depending on if you did it like this. And then what does the y-intercept represent? What does the 6.25 or 6 1/4 represent in terms of the problem? Abby?
The original height.
Good. The original height of the candle. So the candle was originally 6.25 inches tall before we lit it. Okay, the closure is a multiple choice question, but take your time with it and see if you can figure out. It says something about you're calculating your tip and the total amount of your bill. See if you guys can figure out which one that would be while I pass out your homework. You guys will actually have some time to work on that while I can probably pass back your quizzes. Everyone took it in here. Okay, so for the closure, first of all, before we get started, what do you have to do when you are using percents in a problem? If I give you 15%, what do you have to do before you can do any calculations with it? Garrett? Make it into a decimal. Okay, so either divide by 100 or move that decimal point 2 places to the left to get 15%. Okay, which would be 0.15 as a decimal. And so which linear model did we pick? A, B, C, or D. It's representing the total amount that you're paying. So the total of the bill and the tip included. John? Say again? D. That is correct. Okay, so the tip itself was going to be 15% of the bill, which would be 0.15, let's say B, because they used B, plus $1. Okay? But the total bill, remember the bill, is B. So you have to add those two things together. So this is really like 1B plus 0.15B plus 1. Okay, so this was the bill, this is the tip. The total would be adding those two together. which gets us our D. All right, the rest of the time you just work on the homework while I pass out your quizzes.